But again, there is one big issue, and it's a very, very important issue when you do this type of assessments. And then the question is, does the LiDAR on this LiDAR data set, does 0 corresponds to where the sea level is? And this is where we come with a lot of others. So what do you think? Does the 0 on the LiDAR actually correspond? So we do this 1, 2, 3 feet elevation, below. And so we try, but that's a big issue, yes or no? So the answer to this question is actually yes and no. And it's yes because all the LiDAR data is referenced to North American vertical datum of 1988. The North American vertical datum of 1988 is referenced to 1 point, and it's sea level rise, it's mean sea level. But it's mean sea level at Father Point Rimouski in Quebec, Canada. And it's for all the Americas. And it's 1 point. It's not where mean sea level is in Florida. So in order to understand that, I went and pulled this from NOAA, this information. They have a tool that converts the orthometric datums, and those who are in the planning profession for a long time, they probably have worked with NGVD29, so those are where most maps are referenced to this orthometric datum. But so what I did, I went and I pulled this information and converted the orthometric datum to the tidal datums. And this is the mean high water, mean high water corresponds to something that we saw at the picture at the beginning when we have the spring tides. So it's the sum average of the highest of all the high tide waves. So and the mean. So and I went to a workshop with NOAA and the regional compact, all the counties in Southeast Florida, and we voted and decided to actually for sea level rise mapping inundation purposes to use the mean high water, which as you can see is 0.5 feet above the NAVD 88, which is the 0 on the LiDAR. So any sea level rise mapping should start from this point on. So and then I did a completely new maps in which I considered the linear area in the LiDAR, the uncertainty in the tidal surface that was provided by NOAA. So, and according to the methodology that they provided us, we calculated and mapped z-scores to divide probability of inundation and 0.5. So this one is probability of inundation at 80% confidence level. This one is at 95% confidence level. So, and I did also the 85, 90, 95% confidence level. So it's again 1.5 sea level rise, but when you account for the probabilities, it gives you you see that you actually you can derive different maps and different areas of inundation. This yellow area here is the least certain area. So the one that is colored in blue is the one that you have a certainty at least above 95% or above 80% that this area might be inundated. What is in yellow here is and what is in white is the area that for certain would not be inundated. What is in yellow? The area that are the areas in concern that you don't know what might happen. Again, I did the same thing with the 3 feet sea level rise with 80% confidence and with 95% confidence level. So, and then I started talking about mapping human system vulnerability, but where do people actually live? Where do people actually work? Where the clusters of vulnerable populations, infrastructure is easier to get on, and then what are the other areas of critical concern? And with Dr. Sinar and Dr. Lee, we did another study, and this is the Choropleth mapping of census data. The problem with that is that when you do population density or employment density, for example, let's say population density, if you put the land use data beneath the Choropleth maps, you see that you have airports, roads, strip malls, and people do not live there. So in order to make an assessment of how vulnerable populations are, you need to take this area out and actually assign population probabilities to places where people actually live. And so this is what we did here. So you see this is the airport, Port Everglades, there's a shopping malls, the landfill is here. So, and we assign the population density, so now we can make a little bit more clearer assessment where people live and how they might be affected by sea level rise. In summary, the rate of sea level change is faster than expected. The second thing that we need to take into consideration is the regional differences in relative mean sea level, and the contributing factor to these local variations, regional variations, need to be understood and accounted for in local projections. Understanding uncertainty in elevation and tidal data is very important, because 6 inches are probably not that important for the west coast when we have the rocky cliffs and bluffs and rocky headlands, but it's 6 inches are very important for Florida, because as Dr. Becerra from South Florida Water Management District said last week, 6 inches of sea level rise in Florida, they will incapacitate 80% of the stormwater management drainage system here. And finally, the impacts of sea level rise in South Florida will be felt not only on the coast because of the hydraulic connectivity between the ocean and the aquifer, as it happens even in Australia, as you see. So what are the issues that we need to address as planners? Coastal infrastructure. Sea level rise may compromise the performance and safety of all types of coastal infrastructure, including harbors, fishing ports, artificial islands, shoreline protection structures, disaster prevention facilities, waterworks and power generating facilities, drainage and sewage system, and road networks. What shall we do? Designing for a higher sea level now, or retrofitting and modifying these structures later? Shall we rebuild the roads to a high elevation during routine reconstruction from now on? Coastal wetland protection, very important in order, if we want to preserve some of these urbanized area not to be flooded on a regular basis. Building along the coast. Does the economics of coastal development appear to be sufficiently sensitive to sea level rise? I leave this question open. Shoreline planning. Shall a given area be elevated, protected with structures, or abandoned to the rising seas? Nobody has an answer to this question. How to plan for those cases where the shores will retreat and structures will be removed? What will be the economic cost? And some recent studies shows that the human toll will be much less if people plan for that retreat in advance. Density restrictions, coastal setbacks, rolling easements, revising building codes, and floodplain management. Can we reflect the actual risk in flood insurance rates? Is this feasible for Florida or some other places? And then, which way to go? Shall we hold back the sea, as they did in this town of Ellewood-Dyke, Dutch province of Zealand, which is, they can do that because we don't have this porous limestone that we live on? Or shall we create floating cities? Okay, thank you.
Okay, we've got some time for questions. Before I turn up to you, I'm going to take my prerogative and ask you a question. Have you mapped by parcel level, sort of you've identified sort of areas, and what's the population impact? Do you have a sense as to how many people?
We did map the parcels. We did, and we actually calculated the property values and risk. I haven't done this for the population yet. So I just completed this last week so I haven't had a chance, but definitely it's on these posters here. So we definitely we overlay the areas that are at risk with this new population, recalculated population densities. So, but I haven't finished this study yet. Yeah.
But the reason I asked just briefly is we did a project like this in Charlotte County, over on the west coast of Florida. And what we did is when we brought these findings to the local decision makers, they wanted to know how many people and how much money. And it sounds like you're on the same. It's one thing to show them a map, which is powerful, but then to say, and here's how much money, how much infrastructure might be impacted. So I think we've got a few questions. So.
Thanks for your wonderful presentation. I'm curious if I see you've put something together graphically to explain some of your ideas. Have you been able to bring this study and the work that you're doing into the public realm, and how outside of the academic world into, the theme of our conference today, into public understanding?
You know, I've been refraining doing that because the first time I saw these maps was probably like a year ago, maybe a little more than a year ago. And I was horrified. Especially, you know, if you look and you saw, although I said it's not the correct way to do that, the bathtub approach, but you know, just the sheer amount of what's at risk. And then when I was at this workshop with Miami-Dade County and Marcia from Durham, she said, you know, don't talk to me about 7 meters of sea level rise. Nothing really matters to anything above 4 feet doesn't really matter for us. It's, you know, Miami-Dade is gonna pretty much be in there. But you know, I haven't had a chance. And I just finished this part of it, you know, for the climate change symposium last week, so it's just but haven't really had a chance to actually talk to anybody.
Diana, have you considered using ground radar to measure the water table in the ground and correlate that with LIDAR? Are there problems with that as well?
Absolutely. That's a very important point, and actually we've been trying to do that. There is the DHydro database, and I was trying to, but they said it's highly inaccurate. So, but I can easily, if I have a points, I can derive a surface and then see where actually, because one of the recommendations that my thinking about is having all new construction 1 or 2 meters above the water table from now on. Like I saw houses in New Orleans after Katrina, you know, they stand on these pillars that are 2 meters from the ground, and then they have the house built on top of it. So might start thinking about doing, but you're right, we need to know where the water table is, and it's high, for what we have, it's kind of difficult to derive that, but it's there, we'll figure it out. Yeah. Any other questions? Yeah.
Well, what role would monitoring tidal gauges? There doesn't seem to be that many tidal gauges around.
Oh yeah, they are tidal gauges.
That they're recording, and you know, the tide projections by NOAA, you know, that they put out on a daily basis are at locations where they don't really have actual gauges.
You know, NOAA has all the data, so and they did something for us. They created this tidal grid or tidal service, and it has all the variations. Unfortunately, I didn't bring. I have it on my computer. So, but we have what we really want to know. It's not the daily variations, but we want to know what is the mean high water, how high the water can get. So that's what we're really interested in for this type of. And again, but it's
well, yeah, I understand that the tides vary. You know, in fact, we're in another period right now where we're having, you know, astronomically high tides.
It's absolutely.
You know, right now, but just by monitoring the expected values compared to the actual values, I think, you know, would show, you know, some level, and tracking that over, you know, long periods of time would give us good information of what's actually happening to that input, you know, to
yes,
what the
absolutely. Yeah, but NOAA has the data because I've seen the data. It's tremendous amount of data, and I have the maps. I just didn't bring them here to